Alright guys, welcome to another video, and in this episode we're going to write two shaders. The first one is an inverted shader that simply inverts the colors. That is pretty easy to do. And the second one is some kind of earthquake shaking effect. And for this we are going to need random numbers, which we are going to get from the Java code. So we have to let GLSL, the shader, communicate with the Java code. Okay, so let's get started with actually having a look at what we have, because it's not really interesting, it's just a pass-through shader, and we want to change that to an inverted shader. So to do this, we're just going to take a pass-through shader and create two copies of it. We're just going to name them invert. So let's open them up, and we'll see our pass-through shader. Great. So at first, where are we going to edit something? We have a vertex shader and a fragment shader. And since we wanted to edit the color, the fragment shader would be the right choice, because as you can see, we are setting the GL frag color here. Well, I explained that in the last video, so you should probably know that already. At first, this what I marked here is the color that we set this to. So it is the color of the pixel on the texture, and we calculate that using this function and this sampler 2D and the texture coordinate. It's just all stuff from last time, and we multiply this by our tinting color that we get from the sprite batch. So let's take this original color here and put it into a variable called color. So this is going to be a vec4, because that's exactly what it's been before, and it's going to have this value here. So let's just see if this works and put our invert shader in here. And start this up. And yes, it does work, it just doesn't really invert anything. So what we want to do is we want to subtract the value of all the channels from 1.0. So we basically want to have color equal to 1 dot minus color. So at first, the first thing that you should notice is we just say 1 dot, and the color is a vec4, where the 1 dot is a float. Well, we can do this in GLSL. It's just going to subtract every single value inside of color from 1 dot. That's fine. So that's a cool little feature. But we could also say vec4. So we create a new vec4 with everything set to 1 dot and subtract color from that. But why would we do this if we can just do it like this? But if we do this, we'll get a little problem, and that is we don't see anything. That's not because the shader isn't compiled or anything. We can see shader is compiled and we're happy, but well, think about what we actually did there. At first, we want, well, yeah, okay, think about what we actually did there. We had 4 channels, R, G, B, and A. R, G, and B had some value, we don't know that. And A was pretty much always 1, because A is the alpha, the transparency, the how opaque the pixel is actually. And that has always been 1, because we wanted to display it with full opacity. So we are now actually taking 1 minus 1, which makes 0. So we set the alpha channel to 0, and drawing with the alpha channel of 0 is pretty much always going to result in black, which is not what we wanted. So we want to exclude the alpha channel from this calculation. We want to calculate this for R, G, and B, but not for alpha. And that's actually pretty simple as well, because for all vec3s, vec4s, and anything, we can actually say dot RGB, or dot RGBA, or dot RG, or dot GRAB. Grab, cool. We can actually say anything using these 4 letters, because vec4s or anything with 4 or 3 is often used for colors and positions. So the GLSL guys thought, why not let them assess the values like this? So if we set RGB, basically what we're doing now, we are saying RGBA because we don't specify anything, so he thinks we want to calculate this with everything. So this is what we're doing right now. And this is what we're getting. So let's just not include the alpha. We'll just let that out. So we see we just want to subtract RGB from 1, and alpha just, we don't even touch that. And what do we get? A perfectly inverted color map kind of thing. And that's what we wanted, so that's great. But we can also say, of course it doesn't make sense right now, but we can also say X, Y, Z. Actually minus RGB, because they are the same. It's used for colors and positions, so we could also say X, Y, and Z. If we did this, we get the same. We could even do other things, like if we wanted, yeah, just for you to notice, X, Y, Z, and W. The last one is called W. It's not commonly known, but it's called W anyway. We could also say GRB and let RGB like this here. And since this is another order, we are actually going to get different values. So we're going to subtract. we're going to set the green one, the green channel, to 1 minus the red channel. And this is of course not what we want at all, but it's going to look interesting. For example, like this, or like, I don't know, GRB RG. How's that going to look? Oh, also pretty interesting. But yeah, anyway, I think you get the concept. So we want to do this. And there we go. It's inverted colors. Okay, so that's for the inverted shader. Now let's go and create our kind of earthquake shader. So we'll just make some copies of the pass-through one again. Call it earthquake and earthquake again. Let's open them up. Let's set them in here. And yeah, let's actually use them. So those are just the pass-through shader again, nothing invert colors here, forget about that now. So which one do we choose now? We have a vertex and a fragment shader, and what do we want to edit? We want to have some shaking effect, which doesn't really have to do anything with the color, right? So let's edit the vertex shader, because the vertex shader sets the GL position of the vertex. So that's exactly what we want to happen. So what we're going to do is we're just going to add some distortion to our A position. So plus U distort. So U distort doesn't exist, of course. Let's go and create it. U already indicates that we probably want to use a uniform. So it's going to be a uniform vec3 called U distort. Make sure it's actually a vec3, because A position is a vec3 as well. We are not really going to use the Z channel, but we could, and we would probably like to make our shaders compatible to 3D games as well. So it kind of makes sense to use a vec3 instead of just a vec2. So this U distort, if we don't do anything, it doesn't crash or program or anything, but it doesn't really work. So let's try it out. And we'll see we get nothing, because it just kind of initializes our vec3 with 0, 0, 0, and if we add a distortion value of 0, it's no distortion. So we now want to set this from a Java code to get some random numbers. We know that we can get random numbers using mathutils.random and all these kind of methods that we have here from LibGDX or whatever other engine you're using and watching this series anyway. But we have to communicate with the shader, and how do we do that? So we have the shader right here in this shader variable right here, and we want to go into the render method because we want to change this distortion every frame. And now, just to make one thing clear, the shader program is not running all the time. Of course, I mean, that is kind of obvious. So this main method is called every time we render something, and we render something in here. So if we had a look in this method, we would see that it uses the sprite batch, and if we had a look into the sprite batches method, we would probably see the shader being used somewhere in there. But we actually want to use it before we render, so we can just call shader.begin and shader.end. which is exactly what happens somewhere inside of here. But we want to do it before, just in order to be able to set a uniform. And this uniform can be a lot of things, as you can see here. We can set uniform matrices in all kinds of different ways. We can set normal uniforms. We can set uniforms using this number v method to pass arrays in. But we want to set a uniform f, as simple as that. And we still have a hell lot of choices. And we're going to choose the one that takes a string as a name of the variable and 3 values, which is down here. So the name is udistort. Distort, yeah, I spelled that correctly. And then we want to give it 2 random values, mathutils.random. Let's say in range of, I don't know, 4, mathutils.random 4. And the last one is z, and we want to keep that at 0 because that, well, that's how game works. So, well, that's pretty self-explanatory, I guess. We set the variable with that name inside of shader to the values we pass in right here. So if we have a look, udistort is a vec3, so that's x, y, z. We pass 3 values in here for x, y, and z, perfectly fine. We could also pass a vector 3 from libgdx right in there. That would also be fine. Like new vector 3. We have to import it, but yeah, that would also work. But we want to do it like this. Okay, so let's actually go and try it out. And do you see that? It is definitely vibrating, shaking and earthquaking all over the place, which basically means we're done. So have fun writing shaders and stuff you want. I hope you enjoyed this video. I hope you learned something from it. And of course, I hope I'll see you in the next video of this series and maybe other series as well. Until then, have a good day. And yeah, thanks for watching.